If we want to avoid the linear cost of inserting and deleting elements, we have to make sure that our list isn't stored contiguously. Another way to phrase that is, right now the way the array is allocated is everything is grouped up together in one chunk of memory. What we need to do instead is have each of these elements stored in different places in our memory. So we do not want them stored all next to each other, because otherwise what's going to happen is that entire parts of the list would need to be moved even though we're adding or removing a single item. There is another underlying data structure that we can use that is set up where everything is more spread around in our memory, and this is what's called the linked list. And we can actually use a linked list in place of arrays in most situations. The way the linked list works is that we have a series of nodes. So we're not talking about elements anymore. Each element is now a node. And these nodes are not necessarily adjacent in memory. They could be, but they don't have to be. They can be scattered in our memory. And the idea with this is each node would contain the element, so the value of that item in our list, and it also contains a link to the next node in the list. So it would be a link to the node that contains the successor of this list. For our purposes, we'll call this link next, and then you might be asking, well, what happens if we get to the end of this list? If the last node has a link to the next element, what do we do with that? Well, for that last node, the next link will reference what we call null, which just simply means it points to nothing. It doesn't point to anything in our memory. Here's a simple example of our linked list. So each of these blocks right here would be a node. So this part right here is a node that contains the element A0, and then we have this link to the next node, so that's this next, so it points to the next node, which contains A1, and then we have the link that points to the next node, which contains A2, and then we have the next node that points to and contains A3, and then this little mark right here, this represents our null. So this is saying that the node that contains A3, its next link just references null, which means that there's no memory address there. One of the advantages of Java is that it easily lets us implement the linked list. So we can implement the nodes by creating a class for the node. So we would have a class that defines the element that we're going to store, and then also the link to the next node. And then for each node in the linked list, we'll just create an object for it. So our linked list is just going to be a collection of nodes. So let me give you an example here. So this would be the code in Java that defines the node class. So in here we have two members in here. So we have a variable that contains the data. So that would be the element of the node. And then we would have a reference variable called next that would point to the next node in our linked list. Now this is a good reminder, but here's a question that you might be asking yourself. Why can we have a variable type node in the node class? To me, we have this node class and we have a variable type node in there. It seems like this should be a problem whenever we allocate memory and declare the variables, because how do we know how much memory we need to allocate? If I allocate memory for an object in the node class, and then I allocate memory for this node variable, this next variable, how much memory am I going to need for all that? Well, keep in mind that next here is a reference variable, so it stores a memory address. I think we talked about this before when we were talking about advanced Java stuff, where we're allowed to have reference variables be members of other classes. And here we actually can have a reference variable of the same class as a variable in that class. And since the memory address is a fixed size, we're not worried about how much memory to allocate. We know how much memory we're going to allocate for this next variable because it's just containing the memory address. Other methods will take care of allocating the actual memory, what that this memory address would correspond to.